Okay, let's solve for the sample problem number 3. But before we solve the succeeding problems 3 and 4, we will discuss the our next topic, which is uh, the conditions to determine a circle. Okay, so now that we know the standard and general form of equations of a circle, let's now proceed to the conditions that are required in order to determine the equation of a circle. So I have laid out here 4 cases that we that is helpful to distinguish or to determine the uh, equations of the circle. Okay, so let's first analyze the standard form. Okay, here the standard form, as I mentioned from the sample problem 2, to determine the standard form, we need to find the center and the radius. We need to know that the center and the radius. So the center and the radius must be known. Okay, so that condition falls on our case 1. So the values of each k and r in the standard form of a circle are 3 conditions that determine the circle as shown in figure 1a here. Okay. By the way, class, in order to determine the equation of a circle, we need 3 conditions. So in our case 1, the 3 conditions are the given h, k, and r. So as shown here in figure 1. Okay. Now for the case 2, 3 collinear points determine a circle as shown in figure 1b. Okay, like this. So why does 3 collinear points determine a circle? Remember, class, that in our discussion for the module 2 lines, 2 points determine a circle. Okay, right? Now for the circle, 3 points, 3 non-collinear points determine a circle. Why is it so? Let's go back here at the modified general form. You can see that we have 3 coefficients, d prime, e prime, and f prime. So these are all unknowns. So to find or to solve for these 3 unknowns, we need 3 equations. Now, these 3 equations can be found by substituting 3 coordinates that lies on the circle. Okay, and when we have 3 equations, 3 unknowns, we can solve the equations, the system of equations simultaneously to solve for the coefficients d prime, e prime, and f prime. And therefore, we can now solve or determine the general form. Okay, so knowing them gives 3 equations in d prime, e prime, and f prime. Okay, in the slightly altered general form of a circle. Now, case 3, we have 1 point that is, of course, 2 coordinates, x and y. On a circle is a single condition, while each coordinate of the center is also a condition. Yeah. Okay. How does it work, class? Well, when we know a point on the circle and the center of the circle, we can now solve the distance between these 2 points, and that distance is the radius. So we can go back to the case 1 where we now know the center and the radius. So that's how it works. Okay, case 4. Consider the following conditions: the equation of a tangent line, the point of tangency, and another point on the circle. Okay, like this. The equation of the tangent line, the point of tangency, and another point on the circle. So how does it work? So the center on the perpendicular to the tangent the center is on the perpendicular to the tangent at the point of tangency. Okay. So suppose this is the point of tangency, and this is the line perpendicular to our line 1, which is the tangent line. This we know that this line is perpendicular to this tangent, right? The radius is always perpendicular to the tangent, and this line passes through the center. So this must be this line coincides with our radius. Okay. Next, it is also on the perpendicular bisector of the segment joining any 2 points on the center. Okay. So suppose we have these 2 points x1 and x1 y1, x2 y2, and if we connect these 2 points, we have a line segment that is a chord of the circle. And the center here, we know from the properties of a circle in your geometry, in your high school, that a radius bisects a chord, and it is actually a perpendicular bisector. A radius is a perpendicular bisector of a chord. Okay. Now, these two lines determine the center of the circle, and the radius is now easily found. Okay. So how does it work? I will just explain the process. Okay. We have here two given points, x1, y1, x2, y2, and the equation of the tangent line, right? Okay. Now, we can solve the equation of this line segment that passes through the 2 points using 2-point form. So we have one equation, okay? Now, we can also solve for the median by the midpoint, using the midpoint formula. And since this is perpendicular, the slope can easily be found using our relationship that the product of the slope is equal to -1 for perpendicular lines. So we can solve for the equation of this line, right? Now, going back to the tangent line, the slope of this perpendicular line here can also be found because the given equation of the tangent line is known, and from the previous equation, we can solve for this slope of the tangent of this perpendicular line. And since it passes through x1, y1 using point slope form, we can solve for the equation of this line. And then to find the point of intersection of these two lines, just solve the system of equations simultaneously. Then we can now determine the center and get the radius by distance formula, and then proceed to case 1. Okay. Now let's solve for meron pa ba, guys? I have included an important note. While 3 conditions often determine a single circle, there are situations in which they determine 2 circles. For example, a tangent line and a pair of points on a circle determine 2 circles, not 1, as shown here in figure 1b. Okay. So we have the equation of the tangent line and the equation of 2 pairs. Equation of 2 points on a circle, on the circle. So this yields to 2 equations of a circle, the smaller one and the bigger one. Okay. Now let's proceed to our sample problem 3. Find an equation or equations of the lines tangent to x squared plus y squared minus 8x plus 2y minus 152 equals 0 and having slope 1/3. Okay. So ano ba yung required natin, guys? Equation of a tangent line. And the tangent line has a given slope, 1/3, and with the equation of the circle, that is tangent, where our line is tangent, is also given. So let's write first our given. So our given is x squared plus y squared minus 8x plus 2y minus 152 equals 0. Okay. And the slope of our line is 1/3. Now, just a quick verification by if this is a point, if whether this is a circle or a point. As discussed in our sample problem 1, if the coefficient f is negative, well, this must be a circle. Okay, since this is negative, then this must be a circle, not a point. Okay. Now, to visualize the problem, we need to graph it first. So to graph it, we first transform the equation of the circle into standard form. Okay. So x squared, we have by using our formula that we derived in module 1. So, okay. Our d here is -8. Our d is 2. I'm sorry. Our e is 2. And our f is -152. Okay. Now our h is equal to -1/2 d. So we have 4. Our k is -1/2 e. Okay. We have -1, and our radius is equal to 1/2 times the square root of 1/2 -8 plus 2 minus 4 -152. Okay, so what will be our radius? 0.5 times 16 plus 4 plus 152. Okay. Sorry. 0.5, this must be 64 plus 4 times 152. Okay, 13. So our radius is equal to 13. Okay. Now, our center is at 4 and -1, and our radius is 13. We can now graph the circle class. Okay. Okay. So suppose our 4, -1 is located here, somewhere here. Here. I'm sorry. 4 is positive and -1 is negative. So here. Let's say here. There we go. 4, -1. Okay. Now our radius is 13. So just yeah. Okay. Now we also graph our slope that is tangent to the, we graph our line that's tangent to the circle. Okay, so suppose ito siya. Kung tangent siya, dapat it must intersect. Remember that our slope is positive 1/3, so ganyan yung itsura niya. Okay, now posible ba na ilan ba yung possible tangent line with a slope of 1/3 class? Okay, so let's put here our suppose this is our point of tangency, this line here, and let's connect this one. This is our radius, and our radius is 13. It is also possible, class, that we have a point of tangency at the opposite side here, and therefore we have two tangent lines with a slope of 1/3. Tangent, can you please tangent nakasnap talaga. Okay. Okay, hindi na siya nakasnap. Okay na yan. Now, this is the slope here is 1/3. Also, the slope here is 1/3. Let's call this line our line 1. Well, this line, let's call this our line 3. Why? Let's call this perpendicular line, or the diameter of the circle, and its equation as our line 2. Okay. Now, how do we solve for the equation of the line? We have known the slope. So ano na lang ang kulang natin, class? Well, from our special forms of lines, we can use point slope form. We solve for the point of tangency, and once we have solved it, we can use the point slope form to determine the equation of line 1 and line 3. Okay. But class, there are so many ways to kill a cat. There's so many solutions to this problem. Actually, this can also be easily solved using differential calculus. The solution is much shorter, but since we are but I will not show that solution because our subject is analytic geometry. Okay. Now, what I want here to do is a different approach, but you can try it yourself, class, the solution that I have explained. Solve for the point of tangency. We call it as x1, y1, and here we call it x2, y2, right? But what I will do here is a different approach. For me, this is the easier and faster way. Okay. First, I want to determine the equation of line 2 because it is important. By the way, this equation of line 2 is a normal line since it is perpendicular to the tangent and consequently perpendicular to the curve. So this is called a normal line. Now, to solve for the equation of line 2, okay, equation of line 2. Okay. Now, we have a given point for -1. So, isang condition na lang kailangan natin. Since it's perpendicular to our line 1 and the slope of line 1 is 1/3, we can solve for the slope of line 2 using the equation M1, M2 equals -1. So our M1 here is 1/3, M2 equals -1. So our M2 is -3. Okay. Now using point slope form, y minus y1 equals mx minus x1. So our point here is 4, -1, and our slope here is -3. Y plus 1 equals -3 times x minus 4. So y plus 1 equals -3x plus 12, or we have 3x plus y minus 11 equals 0. Okay, so this is the equation of our normal line. Now, why is it important to solve for the equation of our normal line? So this is our L2. Well, let us derive also a relation of the equation of two perpendicular lines. Okay, let's go back to the general form of suppose our L1 has a equation ax plus by plus c equals 0. Okay, now let's transform it into a standard, I mean a slope intercept form. So we have y is equal to -ax minus c, or y is equal to -a/bx minus c over b. Okay, now from here we can see that the slope of our line 1 is equal to -a/b. Then using the relation between the slope of perpendicular lines, m1 m2 equals -1. So if this is -a/b and this is our m2, then m2 must equal to b/a. Okay, now going back to the ball games, I mean formula, slope intercept form for line 2. So let's say that our line 2 mx plus b is equal to, let's substitute the slope of line 2. We have b/a x plus, let's call this, okay, any b, and let's multiply it by a. We have ay equals bx. This will become b times a, but since it is a constant, let's just write this as c2. The constant here for the line 1 we can call a c1. Okay, and rearranging, we have ay, I'm sorry, minus bx plus c2 equals 0. So what can you deduce from this result? If this is okay, I will write the two equations that we have solved. Our first line is ax plus by plus c1, and our second line is ay minus bx plus c2 equals 2. These two are perpendicular lines. Now, by inspection, we can see that the coefficients of x and y interchange. Nagkapalitan lang sila at nagbago yung sign. Okay? Right? So, we can use this very helpful relationship in order for us to solve for the equation of the line. So if our line 2 is equal to 3x plus y minus 11 equals 0, then our line 1 must be from this relation, the coefficients of a and b are interchanged, and the sign of b is changed also, is change from positive to negative. So our line one, the equation of our line must be y minus 3x plus a certain constant c. Okay. So these are families of lines since the constant is unknown. We can call this as families of lines with slope of 1/3. And to find the specific line that we are looking for, we need to solve for C. So how do we solve for C? Okay, let's go back to the ball games again. Here you can see that to find for the C, what relations can we use? What are from the given graph? It is known that the distance of the center to the line is the radius, which is equal to 13. And using our distance of a point to a line formula, we can have an additional equation for us to solve for C. Okay. Now using those class I have included in your module 1, the distance of a point to a line. So I mean yes, module 1. Module 2, I guess, module 2. So just review it, class. So distance of a point to a line. So this distance is the length of the line that is perpendicular to the given line and passes through the point. So what is the formula here? Our distance to a point of a point to a line is equal to absolute value of ax1 plus by1 plus c over square root of a squared plus b squared. Okay. Now we know the point that is 4, -1, and also we know the distance that is 13. We also know the coefficients a, b from here that we have solved. So the only unknown in this equation is the coefficient c. Okay, so let's substitute. 13 is equal to let's just rearrange this class so that it is easier to okay. Let's ayusin lang natin to. The equation must be x minus 3y plus c equals 0. Okay, so this must be, our a is 1. Let's just write 1, and our x1 is 4 plus our b is -3, our y1 is -1 plus c. Okay, over square root of 1, sorry, 1 squared plus b is negative squared. Okay, so that's it. Now, since we have an absolute value here, how can we eliminate this absolute value? First, we need to isolate the term with the absolute value. So this is what is equal to square root of 10. So we have 13, the square root of 10 is equal to the absolute value of, this is 4 plus 4, 8. No. 4 minus 4 plus 3. Sorry, plus 7 plus c. Yeah, okay. Now, to eliminate the absolute value, what we can do is simply to get the plus and minus sign of the other side. So in this case, the left side. So we have our positive and negative value of 13 square root of 10. So we have 7 plus c. So our c now is equal to 7 minus 7 plus or minus square root of, sorry. 13 square root of 10. So bakit dalawang value ng c natin? May minus 7 plus 13 square root of 10 and minus 7 minus 13 square root of 10. So that 2c is the coefficients, actually the coefficients of the two line, L1 and L3 respectively. So eto na yung specific line na hinahanap natin out of the families of lines with slope of 1, 3. Okay? Now, to solve for the equation, we just go back to our line 1. So, ayusin lang natin to class. Meron tayong line 3 pa pala. So, let's call this as line C1 of x minus 3y plus C2 na equals 0. Bakit, sir, parehas yung equation na to? Because these two are parallel lines. And parallel lines have the same coefficients A and B. So remember that class, the relationships. Okay. Now, let's go back to the ball games. We have, for our first line, L1. We have x minus 3y plus negative 7 plus 13 square root of 10 equals 0. So x minus 3y minus 7 plus 13 square root of 10. Okay? Now for our L2, we have same, just yung sign lang yung naiiba. So our L2 is x minus 3y minus 7 minus 13 square root of 10 equals 0. Okay, so ito na yung hinahanap natin na solution. Okay? Okay na? So that's how you solve for the tangent. The equation of the tangent line given its slope and its equation of the circle. Now, actually, this is a long solution because we have employed the principle of analytic geometry. But when we solve it using differential calculus, the solution is shorter. But that is beyond the scope of our subject. So we will not go into that topic. Let's just dwell in analytic geometry. Okay. Now let's solve for our problem set. Sample problem number 4. Find an equation or equations of the circle that is tangent to the given equation at a given point of tangency, and also the center is given, is located or at an equation of the line. Okay. This class is, I'm sure you will solve it yourself if you try it. But let's solve it. Sagutan natin to ng mabilisan because actually this is a very tricky question, class. Okay. And I like tricky questions. So, how do we solve this one? Find the equation. So blah, blah, blah. Okay, now, first, we need to visualize the problem. So let's graph the given lines and plot the given points. Okay, let's first write the tangent line. Let's transform this into slope-intercept form. So we have y is equal to negative 1/2 x minus 7/2. Plus 7/2. Okay, and our next line, 2y I'm sorry. 2x minus y plus 5 equals 0. So we have y is equal to 2x plus 5. Okay. Ano napapansin nyo, class, sa given equation natin? What can you say about the coefficients a and b? They interchanged, and the value and the coefficient of and the sign of the coefficient of b is different. So from by inspection, class, these two lines, let's call this line 1, and let's call this line 2. These two lines is a perpendicular line, right? Okay. Now, well, we can also verify it if we using the slope of the first line is -1/2, and the slope of the second line is 2. So their product is -1. Okay. Let's graph this. This is our. So first, this one, we have a -1/2. So ganito siya, ganito. And the intercept is +7/2. So 3.5 suppose dito. So sabihin natin ito. Next, we have 2x. So pag ganito siya, opposite. And ang slope is 5. So sa taas siya kasi ito is 3.5, ito 5. So nandito to. Ito. Sabihin natin ito. Yan. So ito na yung line natin. Sabihin natin. Ibahin natin yung kulay para maganda. Yan. So ito yung line 2. Ito yung line 1. Now, the point of tangency is located at our line 1. So sabihin natin 5, 1. 5, 1. Sabihin natin ito. Ito, this is 5, 1. Okay? Now, the center is at this line. So, suppose sabihin natin ito. Okay? Now, if we connect these two, this must be the radius of the circle. But let's first determine, recall some properties of the circle. The tangent, the radius must be perpendicular to the tangent line. So this should be perpendicular to the tangent line. So hindi dito yung center point. It must lie here such that the radius is perpendicular. But remember that our two lines are already perpendicular. So that case the case where the radius and the tangent line is perpendicular will be satisfied if and only if the center of the radius is located here. But if the center of the radius is located here and your circle will be like this, then this L1 cannot be a tangent line since it intersects our circle into 2 points. Our L1 is now a secant line. Therefore, what we can say about the problem, there is what? There is no circle that satisfies the given condition. So our answer here is wait. No circle satisfies the given condition. Okay. So wala tayong equation of circle because there is no circle that will satisfy the given condition. So ganyan lang class, and I hope you learned something from our module. I will upload your problem set maybe on Friday. So good luck, and shout out. Pagpasensya niyo na ako class. Shout out nga pala kay Maya Gutierrez, kay Carl Miraflor, and congratulations kay Architect Anarica Garcia for passing the ALE Architect Licensure Exam held on last August 25, 27, 29. So thank you so much and have a good day.